Question 2.58. A hollow metal sphere has inner and outer radii of 20 cm and 30 cm respectively. A solid metal sphere of radius 10 cm is located at the center of the hollow sphere. The electric field at point P, at a distance of 15 cm from the center, is found to be E1 equals 1 times 10 to the power 4 Newton per coulomb, directed radially inward. At point Q, a distance of 35 cm from the center, the electric field is found to be E2 equals 1 times 10 to the power 4 Newton per coulomb, directed radially outward. Determine the total charge on the surface of the inner sphere, inner surface of the hollow sphere, and outer surface of the hollow sphere. So here in this question, you have a hollow sphere which has an inner radius of 20 cm and outer radius of 30 cm. And at the center of the hollow sphere, there is a solid metal sphere which has a radius of 10 cm. At point P, you have electric field E1 that is equal to 1 times 10 to the power 4 Newton per coulomb. The distance of point P, which we will write as RP, is 15 centimeter from the center, which is also equal to 0.15 meter. Then we have electric field at point Q, and E at point Q we will write as E2, which is also 1 times 10 to the power 4 Newton per coulomb. And the distance of point Q from the center is 35 centimeter, which is equal to 0.35 meter. So let's discuss part A of the question. In part A, we need to find charge on the inner sphere. So we need to find charge on this solid metal sphere. To find this, we will use the electric field at point P. Let's construct a spherical Gaussian surface passing through point P. The flux for the Gaussian surface can be given as phi equals integral E dot dA. Electric field at point P is pointing radially inward, whereas area vector for a sphere is always perpendicular to the surface of the sphere, pointing radially outward. So as you can see from the figure, the electric field E at point P and the area vector A are opposite to each other. So when we take the dot product of these two quantities, E bar dot A bar, this can be written as EA cosine theta. And if these two vectors are opposite to each other, theta becomes 180. And we know cosine 180 is -1. So this term over here will become equal to negative E into A. So we get this as negative E. When you integrate over the entire area of the Gaussian surface, you get the area of the sphere as 4 pi RP squared. Now we know from Gauss's law, flux through any closed surface is numerically equal to the charge enclosed by the surface over epsilon naught. So I can find the charge enclosed by my Gaussian surface to be equal to epsilon naught times the flux through it. And this charge enclosed by the Gaussian surface is nothing but the charge on the surface of the solid metal sphere. So we can write charge enclosed as Qs, which is the charge on the solid metal sphere, equals epsilon naught. Phi we will substitute as negative E 4 pi Rp squared. So negative E 4 pi Rp squared. Now let's substitute the values of each term. Negative 8.85 times 10 to the power negative 12. E is 1 times 10 to the power 4. 4 pi times Rp is the distance of point P from the center, which is 0.15 meter squared. And when you solve this, you get the charge on the solid metal sphere to be equal to negative 2.5 times 10 to the power negative 8 coulomb, which you can write as negative 25 times 10 to the power minus 9 coulomb. That is nothing but negative 25 nanocoulomb. Then in part B, They want us to find the charge on the inner surface of the hollow sphere. The inner surface of the hollow sphere is this region here. Now, since there is a charge present at the center, which is the charge of the solid metal sphere, this charge will induce an opposite charge on the inner surface. So if here I have charge of negative 25 nanocoulomb, this negative 25 nanocoulomb will induce an opposite charge on the inner surface. So this becomes positive 25 nanocoulomb. So I can write the charge on the inner surface of the hollow sphere to be equal to negative of Qs, where Qs is the charge on the solid metal sphere. That is equal to negative of minus 25 nanocoulomb. That becomes equal to positive 25 nanocoulomb. Next, part C of the question. In part C, we need to find charge on the outer surface of the hollow sphere. So this region here. To find this charge, we will use the electric field at point Q. Electric field at point Q is E2, which is directed radially outward. We will construct a spherical Gaussian surface passing through point Q. And we know that area vector here will be directed radially outward. Flux through the Gaussian surface can be found as phi equals integral E bar dot dA bar. Since both electric field and area vector are pointing in the same direction, the angle between them is 0. So we get this as E times the surface area of the sphere, which is 4 pi RQ squared. Using Gauss's law, we know that flux through any closed surface is numerically equal to charge enclosed by the surface over epsilon naught. So I can rearrange this to write in terms of charge enclosed. Q enclosed will be equal to epsilon naught times phi. If we substitute for phi from the equation above, we get Q to be equal to epsilon naught E 4 pi RQ squared. So charge enclosed by the Gaussian surface is epsilon naught E 4 pi RQ squared. This is the charge which is inside the Gaussian surface. Now this charge enclosed is the sum of two different charges. First is the charge of the hollow sphere, the entire hollow sphere, plus the charge on the solid metal sphere. These are the two charges enclosed inside the Gaussian surface. I will substitute them for here. We write Q enclosed as charge on the hollow sphere, the total charge of hollow sphere, plus Qs equals epsilon naught E 4 pi RQ squared. Charge on the hollow sphere again is comprised of two different regions. One is the inner region Qi and the other one is the charge on the outer surface. So I will write the total charge on hollow sphere to be sum of the charge on the outer surface plus the charge on the inner surface plus Qs equals epsilon naught E 4 pi RQ squared. We need to find what is charge on the outer surface. So let's move everything to the other side to solve for it. We get charge on the outer surface to be equal to epsilon naught E 4 pi RQ squared minus charge on the inner surface minus charge on the surface of the sphere. Now let's substitute the values to get the final answer. Epsilon naught is 8.85 times 10 to the power negative 12. E is 1 times 10 to the power 4 minus charge on the inner surface is 25 nanocoulomb minus charge on the surface of the solid metal sphere is negative 25 nanocoulomb. These two values we found in part A and B of the question. So when you solve this, you get Q0 to be equal to 1.36 times 10 to the power negative 7 coulomb, or you can write this as 0.136 microcoulomb.